Here we are in chapter 8. There's an 8, section 5, problem number 9. And it's saying perform the indicated test of hypotheses using the p-value approach by testing. There are two different examples. And in these two examples, we are looking, as you would expect, of a sample proportion, since that's the topic of this section. And our sample proportion test statistic is what we'll need to be using. And you can see two different examples here. One's going to be a two-tailed test because our A is a alternate hypothesis that's not equal to, and B is an alternate hypothesis that's greater than, so that's a one-tailed test. So we'll get to do two of those. It says using the p-value approach. So I've got my systematic hypothesis testing procedure, p-value approach, 5-step process. I'm going to call it a cheat sheet, but it's the sheet there from a few sections back in the book that had these 5-step processes to remind myself of them. So okay, let's do this then. For A, I guess on this one we're not worrying about what's going on with the interpreting the value. We're given all our information here. So in our steps, our first step is identify the null and alternative hypothesis. We're given those in the problem statement. So our null hypothesis is that our proportion is 0.37, and our alternative hypothesis is the proportion is not 0.37, and this is at the alpha equals 0.005 level of significance. Since this is going to be a two-tailed test, we're going to need our alpha over 2. That's going to be 0.0025. We'll need to know that number. We have our sample size, n, and our sample proportion at 0.4. And we'll need our Q, which is 1 minus P, which is going to be 0.60. So that should be the numbers we need in terms of identifying our hypothesis. Our test statistic is going to be, let's see here, in this case, it's going to be Z, where our sample proportion minus our hypothesis value divided by the square root of, actually, see what I did there? I did the Q hat. I'm going to need the Q of the hypothesis, which is 1 minus our P there, which is going to be 0.63. There we go. Okay, so we've got our P0, Q0 over N. All right, so step 3, we compute it. And so our Z is going to be our P hat, which is our sample proportion, which was 0.4. I'm going to subtract off our null mean, which was null proportion, which was 0.37. So then we have our 0.37 times our 0.63 divided by our n, which was 1300. Maybe the square root of that whole thing. So when we do all that math, we get 2.24 as our Z value. Okay, so we have Z, of some probability, equals 2.24. So that is actually computing the p-value. Would be computing what that probability is. And since it's a two-tailed test, it's going to be 2 times that. So we have 2 times the probability that Z is greater than 2.24, which is going to be 2 times the probability, which is 1 minus the probability that Z, I keep putting a little bar in there so it doesn't look like a 2, is less than 2.24, which is going to be, let's see, 2 times the probability of 1 minus 0.9875, which equals 0.025. So 0.025. Okay, so that's our p-value. So in other words, the probability of getting something at that level is 2.5%. Our hypothesis test is at 0.005, and our p-value is greater than, so our 0.025 is greater than our 0.005. So it's more likely to happen than what we're looking at. So we're not rejecting the null hypothesis. Okay, so we've got in B. So in B, similar kind of thing, right? We were given the null and alternative hypothesis, so we don't have to identify those. This is a single-tailed hypothesis since it's just greater than. So our alpha at 0.05 is going to be that. So our P0 is essentially 0.94. So our Q0 is going to be 0.06. Our N is 1200. So we are good on sample size and this one as well. And our P hat is 0.96, okay? So identify our test statistic is step 2, and our test statistic is the same that we had before. We have a large sample size, so we are good. And we then use the P hat minus our P naught over the square root of P naught Q naught over N. In step 3, we actually calculate this. So our Z is going to be, let's see, our P hat was 0.96 minus our 0.94 divided by the square root of 0.94 times 0.06. That's a 4 there. I better make that look more 4-ish, otherwise I'd put that wrong into a calculator. Over the N of 1200. And doing the math on that one, I wind up with 2.92. Okay, so computing our p-value is step 4 in the 5-step process. And the p-value is the probability that our Z, since we're looking at, we have a greater than here, is going to be greater than 2.92, which is going to be the same as 1 minus the probability that Z is less than 2.92, which is 1 minus, let's see, probably Z is less than 2.92, that's out of the table, 0.9982. which is going to equal, subtract that, 0.0018. So in step 5, our p-value is, compare that to our alpha, so it's less than our level of significance in this case. So we're going to reject. So this is a yes, reject the null hypothesis in this case. So there we go. We got it.